wanted to talk about for now. We'll maybe get into the other ones at a later date. As for now, let's go back to codefights.com. We're going to take a look at our adjacentElementsProduct task here, and let's take a look at what it's asking.
Given an array of integers, find the pair of adjacent elements that has the largest product and return that product.
Okay. So basically, the idea is that, well, first of all, we should probably talk about some of the wording in here. I mean, like we talked about last time, we are going to encounter some math terms. So first of all, it's an array of integers. That means whole numbers. No 7.5, no pi, no e, nothing like that. So whole numbers. 1, 2, -5. Anyway, find the pair of adjacent elements. So when it says adjacent elements, it means like elements that are right next to each other in the array, like the 3 and the 6, or the -5 and the 7, as opposed to like the 6 and the -5 or something like that. They're not adjacent. They're not touching each other. Okay, so we're looking for a pair of adjacent elements. So maybe it's 3, 6, maybe it's 6, -2, etc. And we're trying to find the one that has the largest product, and then we want to return that product. Okay, so largest product. Well, what's a product? Again, this is one of those math words, kind of like last time we talked about the idea of a sum being the result of an addition. Product just means the result of a multiplication. So that's what that's talking about. So basically what it's saying is we want to look at our array and we want to find the pair of adjacent elements that's going to give us the biggest result when those two are multiplied. So, maybe 3 times 6 would get 18. Actually, you know what? Let's take a visual look at this. So we're going to go over to the whiteboard here. This is also one of my recommended resources, by the way. This is AWW app. Anyway, so taking a look at this, we'll calculate all the products here. So 3 times 6, that'll give us 18. 6 times -2, that'll give us -12. -2 times -5, well, you might remember a negative times a negative gives us a positive, so we're going to get +10. -5 times 7 will give us -35, and 7 times 3 will give us 21. All right, so there we go. We've got all our products here. Now, as a human being, we can very easily take a look at this and say, well, I think this one's biggest. That looks like our winner right there. But we have to think of a way that we can tell the computer to do that. So let's try to think of a set of instructions that are going to make a lot of sense, that are going to be easy to follow. So maybe we could do something like we could toss all of these in an array, and then sort of traverse that array, go from left to right, and find out what the biggest one is. But that wouldn't be super efficient, because we'd have to carve out memory space for another array. We don't necessarily want to do that if we don't have to. So maybe another way we could do this is we could have this variable called, we'll call it max for now. Okay, so max will basically start maybe without a value, maybe with a default value. We'll talk about that. But the main thing is that it's going to go through the array. It's going to go left to right. And it's going to take a look at the value. It's going to compare it to the value of max. And then it's going to see which one's bigger. And if this is bigger, it'll go with that. So right off the bat, max isn't anything to begin with. So when it compares it to 18, it's going to say, oh, yeah, well, that's the biggest number I've seen so far. So it's going to be 18. And then it's going to look at the next one, say -12, and say, well, which one's bigger, -12 or 18? I think 18. And then it's going to look at 10. 10's not as big as 18, so it's going to stay 18, -35. Well, absolute value would be bigger here, but since it's negative, it's considering 18 to still be the bigger number. And then finally, we look at 21 and we say, oh, is that bigger than 18? Yeah, actually it is. So we're going to scratch out 18, replace it with 21, and then basically max is 21. That's what we're going to return. So we'll do something like that for our algorithm. Basically, the idea is that we're going to loop through the array, and we're going to compare. Well, actually, okay. Here's what we'll do. We're going to loop through input array, and then inside of our loop, we're going to calculate the adjacent product, and basically by that I mean multiply it by the next one. Something like that. And then we're going to compare to max, see if it's bigger, and store whichever one's larger. And then finally at the end we want to return max. Okay, so I'm just going to sort of space these out, get a little bit of breathing room between each of these comments, and this is going to be sort of like our game plan here. So we're going to write code for every part of this is the idea. So right off the bat, let's just say var max. Let's just declare it. We'll say it exists, be prepared for it. And then after that, at the end, we're going to do return max. And that's actually, well, that's literally what this comment is saying. So I think this might be self-descriptive enough. I don't know if we actually need a comment saying literally the exact same thing as this. So I'm just going to clear this one here. I think it speaks for itself. Anyway, the point is we're going to loop through input array. So if you remember the syntax from last time, we used a for loop. We're going to do the same thing today. So we're going to say for var I is assigned the value of 0, I is less than input array.length, I plus plus, and then anything that we do in here is going to execute for every single one of these elements. So again, maybe we'll do a console.log and we'll just say I, just to make sure it's working, just to make sure it's covering the right indices. This one has 6 elements, so we should expect it to go up to 5. Remember, there's a 0th element, so it's not going to go all the way up to 6, it's going to go to 5. And that's actually the reason why over here we say that I is strictly less than input array.length, as opposed to a less than or equal to, which would give us all the way to 6. Now, the reason we don't want to do that is because if we actually put in input array here and we're looking at input array at I, so in other words, whatever element input array has at the index I, let's execute this. And okay, so check it out. We've got 3, 6, -2, -5, 7, 3. Those are all the elements in the array, so that's what we expect. And then it's saying, okay, what about after that 3? What do you have after that? Well, we don't have anything, so it's undefined. Okay, so that's why we don't want to make it equal to input array.length. We just want to make it strictly less than. Okay, so now if we run this, we shouldn't get any undefines or anything like that. Nice. All right, great. So but that's not quite what we actually want, right? What we want is to calculate the product. Let's get these comments inside of our loop here. And you know what? It's a little dark in here. Let's see if we can't, yeah, we're on the dark theme. Let's get on the light theme. Oh, no, that's too light. Let's do Monokai. Okay, great. So that's a little nicer. It's a little more vibrant. I mean, hopefully you can see the text a little better. So, okay, let's comment that out for now. Actually, I don't want you to get mixed up with the actual legitimate comment, so let's just delete it for now. Okay, so we want to calculate the adjacent product. We want to multiply the current element by the next element. So we're going to say var product is assigned the value of input array at I, so that's the current element, and we're going to multiply that by the next element. Well, if the current element is input array at I, then the next element should be input array at I plus 1. So, if I is, let's say, 2, then I plus 1 is going to be 3. So it's taking input array at I, which will be -2, multiplied by input array at I plus 1, which will be -5. And we should get 10 from the product there. Okay, so before we move on, let's just do a little console log here of the product. We'll see what it's actually getting. And we see, okay, let's remind ourselves of the numbers here. So we had 18, -12, 10, -35, 21. And so far so good. 18, -12, 10, 35, 20. Oh, look at that. We're getting a non here. So if you remember from last time, NaN, it stands for not a number. We're dealing with something here that's not a number. So why is that happening? that seems a little strange. I mean, we did take care to make this not go as far as the actual input array.length. You remember it didn't actually hit 6, it stops at 5. So why are we getting this non-value? What should it be? What comes after the 21? Oh, well, that's interesting. So nothing comes after the 21. Okay, so basically the idea is this seems to be the problem here. It's this +1 business because, yeah, I is only going as far as 5, but that means I +1 will be 6. So it's trying to do something like this and say, okay, 3 times undefined. And that's where we're getting this non-business. And we don't really like that. Okay, so anyway, the idea is that we've got to be a little more careful about this. So we could do this in a few different ways. We could say something like if input array at I +1, then execute this stuff, and otherwise don't execute it. So we'll see if that works. Okay, great. We're not getting that undefined at the end, but that's kind of strange, I guess. I mean, if input array at I +1. So basically it's saying if that is a number, if it's not undefined, then execute this stuff. We could also just say, if I is, or if I +1 is less than input array dot length, right? Basically saying, is I +1 within the boundaries? We don't want to try to do input array at I +1 if I +1 is not within the boundaries. So this should work exactly the same as the last one. And again, you'll notice we're not getting that undefined at the end. So that's good. All right. But do we need this? Like we're already kind of checking the same sort of thing up here. And if you think about what this is saying, it's basically saying, okay, so for this one, find the product with the next one. For this one, find the product with the next one. For this one, find the product with the next one. For this one, find the product with the next one. For this one, find the product with the next one. For this one, oh, actually, don't find the product with the next one. So it's basically just covering everything up to the second last element. So there's a more efficient way we could do this. Instead of doing this this if statement here, we can basically just say, well, we don't want it to go quite as far. We want it to stop one element shorter of where it was stopping before. So basically, we're going to subtract 1 off of the end index here. And then when we do that, notice we're getting the same exact stuff. There's no difference, but now my claim is that we can remove the if statement. We don't have to worry about that anymore, and it should run just exactly the same way. Great. Okay, that feels good, right? All right, so we've got product. This is working. It's not giving us undefined at any point. So that's, well, that's real nice. Okay, that's a bit more space than we need there, I think. So next thing we want to do is we want to compare to max. I think we're pretty much done with that stuff up there. So basically we want to say if product is greater than max, then store that value in max. Basically say max is assigned the value of product. And that way, max should always be taking on the value of the biggest product, right? If it's bigger than what max already is, store that as max. So let's see how this runs. And okay, that's weird because our output is null. Our output should be max, right? So okay, let's do another little console log. Actually, we're going to move our console log down here, and instead of just product, it's actually going to say max as well. So we're going to look at both of these values. Oh, now look at that. So we've got 18 undefined, -12 undefined. The reason for this is max doesn't have a value right off the bat. I didn't give it a value to begin with. So we could either start by giving it a value, and we'll take a look at how we'll do that, or we could just make this if statement a little different. And look, we're basically reaching a point right here where there are differing opinions on how to do this. Not everyone is going to do this in the same way. So I sort of want to show you what our options are going to be. So first thing I'm going to say is basically if max doesn't exist. So we could say if, well, you remember before we could do something like this. Actually, should I isolate it? No, I'll just do it in here. Okay, so we could do something like this. We could say like if max, and then basically if you remember what we were doing before, basically if this is undefined, it's going to return false. If it has a value, it's going to return true. So I kind of want to do the opposite of that, and instead I want to say if max is undefined, if not max. So anytime you're talking about a Boolean, if you put a not in front of it, that's basically going to give you the opposite. So not true, that'll give you false. Not false, that'll give you true. So it's going to flip it around. So I'm going to run this now, and basically it's going to say, well, if max doesn't exist already, then assign the value of product to max. So now if we take a look at it, we're getting the wrong answer again. Well, this one happens to be right, but again, that's just a coincidence. Anyway, we're not getting the right answer because it's going through, it's saying, okay, for this first one, the product is 18. Does max exist? No, it doesn't. It doesn't have a value. So max is assigned the value of product. Now max is 18. Okay, great. So then it'll go to the next one, and it'll say, negative 12 is the product. We'll compare that. Well, actually, it'll say, does max exist? Yeah, max exists. It's 18. So because of that, it's not going to reassign max. Ever. Never again, because it has a value. As soon as it has that value of 18, it's not going to reassign. It's not going to, trigger this conditional statement again. So basically, we want to say, okay, yeah, if there is no value for max, if max doesn't exist, then definitely assign max the value of whatever your first product is. But also, we want that to happen if product ends up being bigger than the value that max has. So we want to say if it's not defined, or, and this is how we do a logical or. So this is something we can do for Booleans, basically true or false values. And this is logic basically that we're using, Boolean logic. So if you're unfamiliar, there are lots of primers you could take a look at on the internet. I'm not really going to go through the basics right now, but let me know if you have any questions. Basically, the idea is that think of the word or in regular language, So basically, if product is greater than max. So now this is our condition under which we're going to reassign max. Basically, the way it works is it's going to say, well, if this is true or if this is true, then we're going to do this. If neither of these are true, then we're not going to do this. That's basically what it boils down to. Okay, so when we're looking at this, the way to read this, what this is saying is if max is undefined, so if we don't have a value for max yet, or if the product is bigger than the value that max does already have, under either of those two circumstances, it's going to assign the value of the product to max. Let's run this now and we'll see if it works. Hey, look at that. It's passing all of our sample tests. That's a good feeling. All those nice check marks. Wow, there's a lot of tests on this one. That's good. Anyway, okay, so we're getting it done. But like I said, there's other ways to do this. This isn't the only way that we can do this one. So it's not bad. I mean, again, I'm pretty sure this is just a matter of preference. I don't know if there's like a particularly good way to do this. This is one of the ways. Anyway, if we want to take a look at how it's working, we can actually see like max it's 18, 18, 18, and then finally it's 21. So that really, it matches the experience that we had earlier. Okay, so now let's look at some other ways of doing this. So we could just say, well, we could give max a value to begin with, right? So we could say maybe max is 0. Right? And that way we don't have to check if it's undefined because it's going to be defined no matter what. So if max is 0, we'll start with that. And that should work, right? It should be the same. Hey, wait a minute. Okay, so that actually didn't work. It worked for almost all of them, but one of them failed. And if you take a look at it, this is kind of sneaky. This is an array where the elements go negative, positive, negative, positive, negative. That means every adjacent product is always going to be a negative value. And we can see that down here, negative 92, negative 12, negative 24, negative 96. So really negative 12, it's the biggest value. It's the highest value. Oh, ATD, super great question. Yes, we can use map. We are going to use map, but first, we're just going to finish up with our loop over here. Okay, so basically, we're having a problem with this max. It's not low enough because you notice 0 is actually considered a higher value than -12. So we can't just use 0. We've got to use a lower value than that. So how low does it have to be? Well, let's look at our guaranteed constraints here. So this is going from -1,000 to 1,000. These are the elements in the array. So basically the lowest possibility here would be -1,000. And technically, we could have like -1,000 times +1,000 because it's 2 adjacent elements. So that would be -1,000,000. So let's make max -1,000,000 to start with. -1, 0, 0, 0, 0, 0, 0. Okay, and hopefully that should run just fine. Great. So I don't remember which test that was. Was it number 9 that we were having trouble with? No, it was this one. Okay, so now check it out. If we look at it, we've got our product over here, and basically our maximum is adjusting the way we want it to. So it starts at -92, then -12, and then everything beyond that is lower than -12. So we're going to return -12. Okay, great. So that's one way we can do it with the -1,000,000. For what it's worth, there are other ways of writing this. Like we could just do -1e6. And again, if you're getting into the code golfing challenges and stuff like that, you will want to use these kinds of tactics to save bytes. But maybe there's another way we can do it. So we're going to look at one more way of doing this, and then we're going to take a look at .map and some other array functions. So basically the idea is that we want to look at all the products here. So one way we could do this is we could actually start max out as just the first product. We could say, well, it's going to be input array at 0 times input array at 1. And the only circumstance under which this would not work or would work in a way that we don't expect is if there isn't as many as 2 elements in the array. But again, take a look at the constraints. We can see that there's at least 2 elements in the array. So this should be fine. Okay, and then basically, again, we don't need to worry about any other business over here. Let's run the tests, and we find out they still all passed. But we can actually go a step further than that. Check this out. So if we look at this, we can change this to 1 now because we've already checked this first one. We've already found the 18. So we can go right on to the -12 or whatever it happens to be for each particular case. So there we go. We're still passing all the tests. Okay, so at this point, I think since we're passing, we don't really need this console.log. I think this is probably fine. And I don't know, is this the way I would do it? I'm not sure. I would use one of the 3 methods we just looked at probably. Again, I don't know if like one of those is considered better than others. I'm not really sure. If anyone here knows, let me know. But the point is, yeah, I'd probably do it something like this. So we'll submit this. I think this looks good. We've got comments in here to sort of describe what's going on. And you remember, like I said yesterday, that's kind of a good practice to get into. Oh, doesn't that feel good? All right, but I'm not going to continue right now. I'm going to wait for that to fly away, and I'm going to close this. Hey! Look at that, I made it to a new level. So, I mean, another great thing about codefights, sort of gamified aspects of it, going up levels. I mean, it feels great. I feel like I've accomplished something here. Okay, nice. So we passed that one. And yeah, like I was, just to finish up the thing I was saying, we want to make our code human readable. It's sort of one of our priorities in terms of what good code looks like. We want it to be human readable, so it's nice to have a lot of comments in here. So, that was fun, but we're going to take a totally different look at this now. So let's go ahead and clear everything that we have over here. So now, can we use map? Well, let's first start by talking about what map is. So I want to talk about some array functions. Array functions. So these are all going to be built-ins. We're going to talk about map, reduce, filter, sort. And we're also going to talk about this thing called the spread operator. So we're going to look at all of these, and we'll probably call it a day after that. Anyway, starting with map. So what is map? Well, first of all, it's a built-in. It's a built-in that works on arrays. So I'm going to just use input array as an example, and input array dot map. So the idea is that map, it's a built-in function. It's going to work for any array. And the way it works is it's going to go through every element in the array and it'll do something to it. So input array dot map, okay, this is where things are going to get a little bit complicated. We're actually going to use a function as our input, as our argument for dot map here. So it's going to take a whole nother function in there. So I'm just going to start by writing out a function over here. So function, and let's just go with something very basic. Let's make this the add one function. So it's a function that's going to take an input of, let's call this num. Again, if this is your first time writing a function, you can call this whatever you want. You can call this whatever you want, but just try to make it something that's going to make sense to the reader. That's what I'd recommend. Okay, so basically, this is going to be a very, very simple function. It's going to say return num plus 1. Done. Okay, so add 1 num. Now, before we actually get into .map, in fact, I'm going to comment that out for now. Let's just do return add 1 of 5. Let's just test it out. Let's see if it works. So what are we expecting? Well, 6, I think, right? There we go, 6. And that happened to be the answer to 3 of these, so I got lucky with that one. Anyway, let's try -7. We'll try add 1. What are we expecting? -6. There we go. Okay, so that's what add 1 is doing. It's just adding 1 to all of our or to whatever element that we put in here. So now let's see how that applies to map. So now I'm saying I want to do input array dot map, and the function I want to use with map is the add one function. So we're going to run this, and oh, that's weird. I'm getting null. Why am I getting null? Well, I'm not returning anything. So let's actually return input array dot map. How about that? Okay, great. So there we go. Look at that. It's basically just taking every one of the elements here and it's adding 1 to every one of them. So instead of 3, we've got a 4. Instead of 6, we got 7. Instead of -2, we got -1. Instead of -5, we got -4. Instead of 7, we got 8. Instead of 3, we got 4. Great. Okay, so then from here, well, there are a few other things we could do. So we sort of have an understanding of how .map is working. First thing I want to say about .map is it's a non-destructive, it's a non-morphing function. So basically, I'm going to return input array after running the .map on it, and you'll notice input array hasn't actually changed. So this .map, it basically makes a new copy, so I'm going to call this new array, and new array is the one that's going to have the +1s. New array is the one that's going to be like the next levels of each of these numbers, but input array is not changing. That's a super important note. By the way, .map is something you see in a lot of languages, and I don't know actually if other languages do make it morphing, destructive, like if they do actually change the original array or just make a new copy of it. I'm not sure, but in JavaScript it makes a new copy. So that's something to definitely keep in mind, and that's something we're always going to talk about when we introduce new functions, because a lot of them are not that way. I mean, some of them do actually change the original, some don't, so that's something we'll always cover. Anyway, for map, it's not changing the original. We're making a new array, and it's the one where we're actually adding 1 to each of these things. Okay, so we can modify this a little bit. So we could say something like, well, okay, there's another thing that we can do here. So because map is a function that works on an array, that means we can actually get the index of that array as well. So instead of just num, I'm going to get num and index. Okay, so for now, I'm going to make this do something kind of strange. Instead of adding 1 to num, it's just going to return the index. And so then, there we go, 0, 1, 2, 3, 4, 5. So that's not super interesting, you know, it's not really super helpful, but maybe we can make it helpful. So for example, we could do something like, we could say input array, input array at index. And now it's going to look like nothing happened. Now it's going to look like, you know, isn't this the same array as we started with? Well, yeah, I mean, basically we didn't change anything because we're taking the index and we're putting it right back into the array. But the cool thing about this is we can actually do like a +1 here, and now it's going to just give us the next element. Okay, so that's kind of cool, you know. So now basically instead of the 3, we've got the 6. Instead of the 6, we've got the -2. It's basically just shifting it all down. But there is maybe going to be a bit of a problem with that since we have this null here. So that might cause some problems. Anyway, we'll see. We'll see. There are a few ways that we could take care of that. There are a few ways we could take care of the null there. Should we talk about those first? Well, actually, before we talk about those, I sort of want to get into the habit of doing this. So you'll notice this function over here is it's the add1 function, and we're just popping it right in there. So what I'm going to say is, if we're only using this function for this dot map here, then why not actually just take the function and put it into the dot map? So now we have our function in here, and we don't have to worry about re-referencing it. Is it still going to work though? That's the question. Yeah, it still works. Okay, great. And here, I'll take it a step further. Well, since we're not referencing this function anywhere else now, we don't need to give it a name. So that's a nice thing about JavaScript. It allows you to make these kind of anonymous functions, functions that don't need to have a name because they're done with so quickly. So since we're only using this function for the dot map, we don't need to give it a name. We can just say function, num, index, this is what it does. Okay, great. And let's even go a step further than that. So if you remember, I think in the last broadcast we talked about arrow functions. Arrow functions are basically where we would take this function and instead of expressing it like this, we would say something more like add1 is assign the value of something that goes from num and index to input array at index plus 1. These two things, this function here and this function here, are doing almost exactly the same thing. Not quite exactly the same thing, but almost exactly the same thing. So I could actually just take this and just cut that out and put it in here. I'm just going to clear this junk up there. And now this is, well, it's getting pretty terse, again, it's doing the same thing, but we don't have to write a lot in order to actually get this done. So basically we just have our two inputs and we're going right to the output. So then we might ask ourselves, well, hey, look, we're not actually using num right now, so maybe we don't need num. Maybe we can get rid of it and just use index. Well, let's take a look at that. Let's see how that runs. Oh, that's not very nice, is it? We have a bunch of nulls in here now. This really looks like garbage, actually. So what's going on here? Well, the thing is, the way map is going to work is expecting a function where the first argument is the number itself, the element of the array itself, and the second element is going to be the index. So even though we're not using the number right now, we do need to keep it there because otherwise it's going to think that the index is what we're using for num, for the actual element of the array. So we do need to keep it there even if we're not going to use it. But hey, let's use it. Let's actually use it. I mean, we do want to use num. We want to use it to do something like, well, this. We basically want to take the current element and we want to multiply it by the next element. I mean, that's basically the name of the game right now. So if we run the tests on that, okay, great. That's more or less what we're looking for. The problem is this null at the end. So let's talk about a few ways that we can take care of the null. So I think we're probably good with map now. We sort of have an understanding of map. Let's move on to filter. So we'll talk about filter next. Filter is very cool. It's a lot like map. So let's call this one filtered array. And it's going to be assigned the value of new array. Well, actually, you know what? Let's play around with this for just a sec. So first of all, filtered array is the thing that we want to return now, and right now it's just input array, so it's just going to be the exact same thing as input array. But now I want to do a dot filter on here. So again, a dot filter is going to take a function in, and it's going to execute it in a slightly different way than map. So the way map works is it's basically going to take that function and apply it to every one of the elements. The way filter is going to work is, and actually I'm just going to comment this guy out now because we're not using it yet. The way filter is going to work is it's also going to take in a function, but it's going to run that function on every element, and basically if it gets true as a result, it'll keep the element in the array. If it gets false, it'll remove the element from the array. So let's say I wanted to use filter with a function that's basically just going to take the positive elements. So if we were to take out all the negative elements here, we should expect just 3, 6, 7, and 3 left over. So we could do something like function x, and then the way this function is going to work is it's going to say return, or actually let me do this one step at a time. If x is greater than 0, then return true, and if it doesn't make it that far, then we'll return false. We could have put an else there, but it's not necessary because if it doesn't get caught on this, then it'll make it down to here. If it does, it won't, because it'll return true. So take a look. We only have the positive elements remaining. Okay, so that's nice. But again, the thing is, we probably shouldn't ever do something like this. It doesn't really make sense to say, if this is true, return true. Because look, if this is true, well, why not just return that? So we can actually rewrite it that way. We can just say return x is greater than 0. And then that should work exactly the same way as what we had before. So we're expecting 3, 6, 7, 3. There we go. Just the positive elements. Okay, so that's nice. That's getting a lot more efficient in terms of how it looks. But again, it can get even more efficient than that. We can use an arrow function, and this is going to get really nice and tight, and that's all we need. Input is x, output is the Boolean, x is greater than 0. If this is true, it'll keep the element. So 3 is greater than 0, it keeps 3. 6 is greater than 0, it keeps 6. Negative 2 is not greater than 0, so it doesn't keep negative 2. And it also wouldn't keep an element of 0 in there either. Okay, so that's dot filter. That's the way dot filter is going to work. But why did we bring out dot filter? Well, it's because of this. Remember, new array had this element that was null at the end. So maybe we'll switch this back to new array for just a sec. And right, there's the null. Okay, so we can make this filter act on new array. And now it's going to filter out, and we'll change this. So instead of x being greater than 0, let's just say if x exists, then we want to keep it in the array. And if it doesn't, we don't. So this is kind of a silly looking function to say x is mapped to x. But that's what we're looking for. We're saying the input is x, the output also x. If this is a value that would be typecast to true, then keep it. If it would be typecast to false, don't keep it. So numbers, any number is going to get typecast to true. But null is not. It's going to get typecast to false. Okay, so let's run this, and basically what we should expect, there we go. We don't have the null on the end anymore, so that's pretty nice. We just have the products. The question is, will it always be nice? And the answer is no. We have a problem in this case, because if we look at what our products should be, we should have 1 times 2, which is 2, 2 times 3, which is 6, and then 3 times 0, which is 0. We're missing the 0 on the end. Why is that? Well, it turns out it's because 0 is considered false in JavaScript. So basically our filter is saying, well, the 0 is false, so I'm not going to include that 0. So maybe filter isn't the best way to do this. So instead of filter, we're going to use something else. We're going to use something called slice. And that wasn't in my list, so maybe I'll just add it to the list. Slice. All right, so we're going to use slice more later on. It's a really, really useful built-in for arrays. So let's just actually go down here. We'll say new array dot slice, and I'm just going to put in some sort of random values to no, those are kind of big, 1 and 4, let's say. Okay, so now let's return this, and we'll try to make sense of what it's returning. So okay, we're getting negative 12, 10, and negative 35. And actually, you know what? Let's, just so we can look at it very easily, let's do a little console log so we can see both the new array and the result that we're getting. Okay, so this is what we were getting with our console log. We got an array containing 18, negative 12, 10, negative 35, 21, none. All right, and then we're saying slice 1, 4. So the way that works is it's going to include element with index 1. It'll go all the way up to element with index 4. But it will not include that one. So it's basically, yes, include 1, no, don't include 4. So it's just going to take negative 12, 10, and negative 35. Okay, so that's a nice slice. But it's not exactly the slice we're looking for. We basically want it to go from here, from the start, all the way up to the second last element. So basically we'll say, all right, start at 0, and then end at this one right here. So what would this be? 0, 1, 2, 3, 4, 5. Okay, so 0, 5. Let's run that. So we're returning just a slice of the array. Okay, great. So now we don't have the non on the end. That's great. But the problem is, it's not going to work the same for all of these because the 5 was only applicable to this one over here. So we have to make it something that's actually going to change with the array. So we're going to say it's input array, not input array, in this case new array. So it's new array dot length -1. And now what it should be doing is great. It's cutting off the last element there. It's cutting off the last element there. It's cutting off the last element there. So now we don't have to worry about that last element, and we can basically just take the maximum value of new array. And actually, you know what? I'm going to rename new array. I'm going to call it product array. In fact, it's kind of self-explanatory that it's an array, so I'm actually just going to call it products. Again, we always want our names of variables to be pretty clear about what they're describing. So, okay, I think we've got everything we need over here. This should still work. Great. Okay, so now basically all we need to do is find the maximum value in this array. The way we're going to do that is this. We're going to use reduce. Or at least we're going to use reduce for now, and then we'll look at some alternatives after that. Okay, so return products.slice. Oh, okay, so actually I'm realizing something now. What I should have done is maybe kept this one as new array and then say var products is this, because really products should not be including that that null or non that we had at the end there. Okay, so products. And now what we want to do is we want to return products. Okay, great. So this should, great. That looks great. Okay, so we're going to learn about reduce. So reduce is one of the most interesting array functions. It's also one of the most difficult to understand. So we're going to spend some time on it. The first thing I want to say about reduce is just like these other ones that we've been looking at so far, it's going to take a function as its input. And just like the other ones that we've been doing, I'm going to start with the traditional notation. So I'll say function, and I'm going to say a, b, and then we're going to open this up. So what is this going to do? So first thing to notice, it's taking two inputs. But these two inputs are not the same as the ones we were using in the map. For map, it was the number and the index. For this one, it's going to be, well, maybe like the first element and second element. It's not quite that, but it's something sort of like that. So we're going to do a reduce, and I want to do something really simple to begin with. So return a plus b. Okay, so let's return this thing. And oh, by the way, in case anyone's like wondering about why is there a return here and a return here. So it corresponds to the function, the most deeply nested function. So basically this function is returning a plus b, but this function is returning products.reduce, all that stuff. So I know it can get a little confusing when there's multiple returns in there. That's actually kind of one of the advantages of using these arrow functions, because we don't have to worry about that so much. Anyway, the point is, so we want to do this reduce. Basically, the idea is that, well, we're going to do AB. Let's just see what we get from that. So A plus B output 2. Okay. Well, that's weird. Why are we getting 2? So, okay, my console log is giving us a new array, but let's actually get products as our array. Okay. So, products. Now that should be the same as what we were seeing already, except yeah, great. So where's this 2 coming from? I mean, I said a plus b here. How's that relevant to the 2? Well, let's take a look. So we have this array. It's basically this right here. So let me clear some of the other stuff that we have on the whiteboard right now. And I basically just want to zoom in on this array that we have down here, because it's the one that we're working with. And okay, we don't need that max anymore. And hey, tell you what. Whoops. No, I didn't want to fully delete that. Let's just turn that from upside down. There we go. Okay, so here's our array, and these are our elements in the array. Okay, so basically, let me recenter this a little bit. There we go. And we'll talk about how this is working. So let's go back here for a sec, return a plus b. So I want to talk about a and b. So a is going to start as this value 18. A starts just as the first value in the array. And then b is going to be, I'll put it on this side over here. So here's b. b is going to start as negative 12. Okay, so A is 18, B is negative 12. So it is kind of the first and second element of the array, but only at the start. So basically, we're going to return A plus B. And A plus B, if we think about it here, 18 plus negative 12. Well, I'm not super great at math, but I think the result there would be 6. So what is it doing with that result? It's returning it as the function. And the way reduce works, like I said, it's kind of complicated. It's a little weird, but it's actually super, super useful. So it's a good thing, and so it's worth understanding. So 18 plus negative 12 was 6. It's actually going to store 6 as the value of A in the next step, in the next iteration here. So A is always going to take the result of the last time it ran the function, whereas B is always just going to take the next element in the array. So now we've got 6 and 10. So again, return A plus B, we want to add 6 plus 10, and so that's going to be a 16, and we're going to store it as A. So now A has 16. Okay, and then B is going to take the next element in the array, so B is going to be 35. And the next thing to do is going to be to add 16 and 35. Oh boy. Sorry, negative 35 and 16. So let's see. Let's start with negative 35 plus 10. That's going to be negative 25. Negative 25 plus 6. That's going to be negative 19, I guess. Okay, so we've got negative 19. That was tough. And then we'll take the next element in the array. That's 21. Great. Okay, so we've got our 21 here, and now we're going to add these together, and the result of that is 2. And then for B, we're going to take the, well, there is no next element. We can't take a next element. There's nothing left there. So we're just going to take this 2, and we're going to say, well, there wasn't anything left once we got to this 2, so that's going to be our final value. That's what we're going to return. So 2. Well, that explains how this got here. So that's the 2. The 2 is basically the result that we got when we added up all the elements here. So reduce is really cool because it goes through each of the elements and it kind of stores the value. So even though it's just saying A plus B, this is the same as saying add up all the elements in the array. So basically the products array, if we want to add up all the elements in there, this is what we would do. Function AB, return A plus B. Again, we could just do an arrow function, AB, arrow A plus B, and we will eventually do it that way. But first, I want to modify this because we can do something pretty cool with this. So basically, instead of A plus B, we're going to say, we'll just one step at a time. If A is greater than B, then return A. It's going to take the bigger one. Else, return B. Okay, and we'll see what happens there. So basically, we'll look at that. It passed the test. Why did it pass the test? Well, let's think about how this function is working. Maybe if I want to erase these, maybe I'll just do like a billion undos. Actually, that was more undos than I needed because I actually do want to have negative 12 here. Great. So now it's basically saying if A is greater than B, return A. If it's not, return B. So it's just going to return the bigger element. So it's going through these and it's going to say, hey, which is bigger, 18 or negative 12? 18 is bigger. Okay, what's the next one? Next one's 10. Which is bigger, 18 or 10? 18's bigger, so we're going to keep it 18. What's the next one? Oh, wow, that's quite an 8. Next one's negative 35. Which is bigger, negative 35 or 18? It's 18, so 18 is bigger. And yeah, that's the sort of thing that's going to bother me. So, okay, 21 is our next one. Which is bigger, 18 or 21? Well, actually, it's 21. And then, again, we're out of elements. So we just say, that is your result, the 21. And that's the result we were looking for, 21. Okay, awesome. So this is working the way we wanted to, but, there's a lot of lines in there. We can clean this up a little bit. So the first thing I wanted to mention is, again, as soon as it returns, it's not going to execute anything else. So basically, we don't actually need the else here. We can clean this up a little bit. And we can just say, well, if it didn't make it to this return, that must have meant that A is not greater than B. So in that case, B is bigger, so return B. Okay, so that should still work the same way. It should pass all the tests. Great. And like I said before as well, we don't need the braces here since it's just one line. We can just do it like this. And now, it's getting more compact, which is nice. We could even use a a ternary operator here. So ternary operator is basically going to do the same exact thing as this, and it's going to do it more efficiently. So instead we're going to say return, and the way this is going to work, ternary operator, we call it ternary because there's 3 parts to it. So the first part is the condition. The first part is, the question we're asking. Is A greater than B? And then the second part is going to be the sort of the answer if that's true. So if A is greater than B, return A. And if it's not, so we use a colon to separate into the third part here, which is what it's going to return if this statement here is not true. So now this stuff up here, exactly the same as this stuff down here. We can get rid of this, and we should expect it to still work exactly the same way. So we run this, and it's passing all the tests. Awesome. So that's nice. That feels good. But could it get more efficient than that? Let's find out. So A is greater than B. Return A, otherwise return B. Well, really we're just looking for the maximum here, right? We're just looking for, hey, which one of these is bigger, A or B? So we could just do a Math.max with A and B as our arguments. Okay, so Math.max. This is another built-in. We talked about the math library last time. It can do lots of cool stuff for you. Max is it's another one of the very commonly used functions. Min is, well, you can probably guess what min does. So again, this is totally working. It's doing what we want it to be doing. That's great. Okay, so Math.max, Math.min. And we've got reduce here. Again, we could make this into an arrow function, make it look nice and pretty. There we go. Okay, so that's getting better, and there we go. So that should work. Okay, and it does. All right, so that's pretty cool. So return products.reduce, A and B gets mapped to Math.max. Okay, so at this point, we've talked about map. We've talked about reduce. We've talked about filter. We've talked about slice. We have not talked about sort. So now we're going to talk about sort. And I don't think you're going to be too surprised by all this. It's very similar to the ones we've seen before. It's going to work on an array. And actually, you know what? I'm just going to let this run, and I'm going to see what we get from this. So -12, -35, 10, 18, 21. This doesn't look sorted. I mean, we should expect the -35 to come first. So this is kind of strange the way it's sorting these. Maybe we can take a look at some. So this one looks good. 2, 3, 4, 5, 6. That's what we'd expect. 0, 2, 6. Are there any other weird ones that we're seeing? Yeah, there are. This one's especially weird. So this one actually looks like it makes no sense at all. We start with -24. We got -46, then -8. So we're going down, then up, then way up, then down, and then the same number. So why is this sort working so weird? Well, the reason is because it's sorting these lexicographically. It's sorting them as though they were strings, as though they were words. So it's just looking at the first character and saying, oh, well, negative, so anything with a negative is going to go first. And then what's the next character? For all these 3 that have negatives, well, 2, 4, and 8. Well, we would order those in that order. 2, then 4, then 8. And then if it has another character after that, okay, then the 4, and then the 6. So basically the idea is it's trying to arrange these like they're words. Well, that's not really that useful to us. So luckily, sort is just like the other ones. We can give it an argument. That's a function. And this function works differently than some of the other ones. So basically, the idea is that it's going to take either a negative or a positive. That's what it's looking for. It's not looking for a true or false. It's not looking for a 1 or a 0. It's looking for a negative or a positive. And I think the idea is, like, if it's negative, it's going to switch them. If it's positive, it's not going to switch them. That's kind of the idea. Anyway, so we'll do return A minus B, and we'll see how that sorts them. So that sorts them basically from lowest to highest. So that's nice. And then we could switch this around. We could say B minus A, and that's going to sort them from highest to lowest. Okay, so that's pretty nice. And again, we can make this an arrow function. It's probably, this is one of the areas where I use arrow functions the most. For any of these array functions, I like to use arrow functions just because it keeps it nice and compact. You know, this is a lot nicer than what we were dealing with before. We don't have to worry about those extra return statements and stuff like that. So we could say something like var sorted array, or here, better yet, sorted products. We're being very clear to the reader about what this means. And then we can return sorted products. And that's just going to give us the same array. But hey, check it out. The biggest element, the one we're looking for, it's the first element. Or the 0th element. So basically, we'll take element 0, and boom, we're done. We're solving it just as well as we were before. That's great. Okay, so then, okay, that's basically how sort works, and maybe that's a useful way of doing it. But there's one last thing I want to talk about here, and it's this spread operator. So specifically, the way I want to use this spread operator is, well, I want to revisit this Math.max thing we were looking at before. Math.max or Math.min. I mean, they work very similarly. I'm just going to do a return up here, and that's, as we spoke about, it's going to ignore all this stuff, because as soon as a function returns something, it's done. Okay, so Math.max, 3, -7. So we should get 3 out of this one. But what if we had some other elements? What if there's 5 and 17 in there as well? So can it handle multiple arguments? Yeah, it can. So basically, it's taking 17. It's taking the biggest of them. So if we can do Math.max with a whole bunch of elements, then let's not worry about this sorting stuff. Let's just go down right here and let's say return. Well, first of all, let's go back to products just so that we can see what that looks like. And I'm going to clear this so that that stuff actually executes down there. And let's just get rid of some of this breathing room. It's excessive. Okay, there we go. So that's our product array. So now let's just do Math.max products. Cool. So Math.max products. Oh, we're getting a null. So, okay, this is strange. Why are we getting a null out of this one? Well, the idea is that Math.max, it wants to take lots of arguments, but right now we're not giving it lots of arguments. We're giving it one argument. We're giving it one input. The only thing we're giving it is this big old array. And that's no good. We don't want to be giving it a whole array. We want to be giving it the things inside that array, just the 18, -12, 10, -35, 21. So here, let me copy this and actually put that in here. So basically, this is what we're giving it right now. And you'll notice when we run that, it's going to say, what are you talking about? That's null. That doesn't make any goddamn sense. Okay, so let's get rid of those. And now it should work just fine. Okay, so basically that's the idea. We want to find a way to take the array products and just turn it into more like a list of arguments. That's those products. So the way we do that is this spread operator. Spread operator is just a ... or an ellipsis if you want to get fancy. Basically, the idea is now it's going to take everything that was in products, and instead of taking all of this, it's just going to take all of this. So let's run that, and it works. Okay, great. So nice to see all those check marks. We're passing all the tests. Everyone is very happy, and we're pretty much just done. So we can get rid of the console.log. We've got products. We've got our new array up there. So, okay, we're done with all that stuff. But the question is that the most efficient way of doing it? I don't know. Let's find out. So basically, actually, I just deleted the console log, but I'm going to pop it back in here. So console.log of products. Okay, now the reason I want to see this is because let's take a look at the way we're handling this. So products is basically new array, but then we're slicing it. What if we weren't slicing it? So going back to new array, what was it that we were trying to chop off? Okay, so we were trying to chop off that last number there. We were able to do it with new array to length -1. There's a more efficient way we can do that though. So check it out. Over here we had the non at the end because we were saying we want to compare each of these elements to the next element. So 3 has a next element, 6 has a next. And the only one of these that didn't have a next element was this 3 at the end here. So that's why this last one was becoming the non. But now I want to switch this. So instead of the next element, now we're actually going to get the previous element. Okay, so now notice how the non is at the beginning instead of the end. You might think, well, yeah, big deal. What difference does it make? Well, it makes a difference in terms of the slice here. The slice is no longer accurate because if we take a look at products, yeah, I wanted to show not new array but products. So let's take a look at what products is doing now. So products is chopping off the wrong thing. It's taking off the last element instead of the first element. The reason I wanted to do it this way is because you won't believe how much easier the syntax is. Check this out. Boom. So that's it. That's actually all we need. It's just going to take the first element off, and it's going to keep everything else. So if you use slice, if you don't put a second argument on it, it's not going to stop. You know, the second argument is normally like where to end. Here's where to start. The other one is where to end. So if we did like 1, 4, in fact, I think that's what we had before. We're stopping at the fourth element here. We're not going to have another thing after the 10. Whereas if we don't include that, then it's just going to keep going until the end of the array. So that's good. That's what we want. We want just the ones that are products. Okay, so that's great. Dot slice 1. And you know what? I'm actually just going to clean this up a little bit. I mean, again, I don't necessarily advocate using these one-letter variables here, but the reason I'm doing it this way is because I don't like the way it was sort of cutting off and bleeding into the next line like that. I want to keep it kind of tight. Okay, so n is the actual element of the array. I is the index of that element, so it's saying the element in the array multiplied by that element with the previous index. And again, it's going to freak out for the first one because it's going to say, well, this doesn't have a previous index. What do you want me to do? And that's why we're slicing off that value. Okay, so check this out. This is kind of cool. We're basically saying new array, right? New array is all this, and then we're doing a slice on that. So let's actually just replace that. Let's cut that out, and we're going to cut that out as well. And instead of new array, we're going to paste in what we had. Okay, great. So again, just because this is getting a bit long, I'm going to shorten my array name. So instead of input array, we're just going to call it A. That's saving a lot of characters. But okay, there we go. Product. It's still working. Okay, so we got this thing. And we don't need the console log anymore. And in fact, check it out. We've got products over here. Product is just this thing right here. So we can cut that again, replace products with that. And there we go. We've got pretty much a single line now. And in fact, we can make it legitimately a single line by making this into an arrow function. And now we don't need the return anymore because it's just a single thing that it's returning. So look at this. That is all we need. That solves it. The question is, and this is the same question we asked ourselves before, is this better? You know, is this a better way to do it than what we had before? Well, what did we have before? Let me just copy this just in case he clears it. But well, let's take a look. We can look at all the solutions here, so we'll take a look at the one we submitted. Okay, so this is what it was looking like. Basically, it's looping through the array. It's finding the product. And then we're comparing that to... I can't modify that. Okay. I think I know how to get this. So let's copy this, and then we'll go back to description. There we go. So, okay. We're basically comparing these two implementations. Well, let's assess this on the basis of what we were talking about last time. So if you remember the last time we met, we were talking about these 3 fundamental questions that we're aiming to answer with this whole stream experience. So one of those questions was, what does good code look like? We found that we sort of nailed it down to 3 main things. Number 1, good code is it minimizes the computation time. And in particular, I mean, there's this concept of time complexity. It's not just how long it takes to run the code. It's as you scale up the size of the inputs, as your arguments get bigger, how does the computation time scale according to that? So is there a linear relationship between the two? Is there a quadratic relationship, a logarithmic relationship? And basically the lower the slope on that relationship, the better. Anyway, the point is, we'll talk more about time complexity later on. I mean, there are sort of formalized ways of looking at it, but let's just sort of look at what these 2 algorithms are doing. So if we look at the first one in terms of computation time, so we're running a for loop. I mean, that'll take some time, but that's directly proportional to the size of the input. So that would be kind of like a linear relation. We're running that for loop, and we're comparing it to this max value. And basically, if it's bigger than the product, then we're going to change the value of, if the product is bigger than max, we're going to change the value of max. And then at the end, we just return max. So in this case, we run through the array one time. So yeah, this would be like a linear complexity. In terms of memory, that was the next thing. We want to sort of reduce the amount of memory we're taking up as much as possible. So that's why I was saying before, we don't necessarily want to make a new array for all the products here if we don't have to. In terms of memory, looking at this one, well, we're not creating any new arrays. We've got this other variable max, but we're not really taking up a lot of extra memory here. Okay, so then the final thing was human readability. We want a human being to be able to read our code. And again, that human being might be the future version of yourself when you're revisiting this thing. So, if you're not doing it for anyone else, do it for you. Make sure you can understand this. So, which is more human readable between the two of these? Well, this one's shorter, but it doesn't have any comments. We're not necessarily using a lot of code that necessarily speaks to the reader what it's doing. Like this whole for thing, it's pretty clear that it's going through the array, whereas the dot map, it might not be as clear. It might not be clear to the reader why we're doing this dot slice. We'd have to add a comment or something like, do the dot slice so that we don't have a none at the beginning. Anyway, it's something like that. The point is, I think this one is clearly more human readable. We found this one, it doesn't take up a lot of memory, it doesn't take up a lot of computation time, whereas this one, well, let's analyze it for a sec. So we're doing a dot map. Right off the bat, that's going to go all the way through the array. Okay, and then we're slicing that. In terms of the time complexity there, well, let's think about it. That's creating a new array. When you do a dot slice, it makes a new array. So that would take up basically memory equal to the size of the original array. And then finally, we're doing the dot max on the spread operator. So we've at least got to iterate through that array again. So in terms of computation time, in terms of memory, in terms of human readability, this is pretty much the better algorithm in every regard. So the only real thing about this, I mean, if we were doing a code golfing challenge, yeah, obviously this one would win. But that's like, in terms of writing short code, in terms of minimizing your number of bytes you're taking up, that is really not going to be one of our priorities. Our priorities are optimizing computation time, optimizing memory, and making it human readable. So I would recommend the second algorithm here. This is the one I would probably say it's a good idea to go with for all the reasons we just mentioned. So I think we covered everything we wanted to today. Let me know if you have any questions or anything like that. Again, just as a reminder, if you guys want to add me on codefights, if you want to be code friends, then use ZeroCool. That's the account that I use for code friends. I'm not keeping any code friends on this JS the game account, just because I don't want like pop-ups and stuff like that when we're in the codefights environment. So yeah, ZeroCool if you want to be code friends. Anyway, thanks a lot for watching. I'll see you again next time, where we'll be talking about the the next one, shape area. Maybe some other stuff. I don't know. We'll find out. You'll have to tune in again. Anyway, bye.